where we stopped last week. So mm, so yeah. So this is where we stop. So I said data frame is like creating a document that looks like a table, both rows and column. So I was trying to like use this example to like illustrate how to create a data frame. So we are trying to create a data frame now. So in each data frame, it's just like data frame is like a collection of vectors. It's just collection of vectors. So we are going to create three vectors. Then from the three vectors, we are going to like create our data frame. So we need three letters because this function letter in R. Okay, let's try something. Letters. Yep. Once you run this particular function in R, this particular letter, it's going to give you the list of alphabets that we have from A to Z. So it's going to give you this. So we are trying to like select the first three. That was why we use the Q bracket and 1 to 3. So this is going to select A, B, and C. So this what this line 149 does. So we save this into L3, that is three alphabets, that's A, B, and C. So we need another vector called fact. So we create this by selecting from these three alphabets, because we use a function called sample. What sample does is that is sampling. It's kind of like it's a method of selecting, like from selecting some samples from the population. So depending on how you want it, so depending on how you want your selection method to be, so we try to like say, oh, let's we are sampling from the three alphabets, and we want to select 10 sample. We want it to like from the three, from A, B, and C, we want to form a sample size of 10. So, and we set replacement to be equals to true, because if we fail to set replacement equals true, we have only three observation. There is no way we can form a sample of 10 from three observation without without setting replacement to be true. That is why we like have this function called sample. So we use the function sample L3, which was what we've saved already, L3. Then it takes size. This takes size. So our size is 10. So it takes size, and replacements equals true. So once you run this, coming sample, okay, L3 not found. Oh, sorry. So once you run this, okay, it's going to like select from between A, B, and C. It's going to select them 10 times to like create 10 observation from those three alphabetical order. So alphabets. So this is it tries to just select A, B. It's repeats A twice now, because it repeats A multiple times because we set replacement to be true. That is, it can select A the first time, select A the second time, select A the third time. So it's like a fair kind of method of selection, because it gives every sample unit in the sampling distribution equals chance of being selected. So this is what this function does. So we write this into a variable name called fact. So we are trying to like make our data frame. So the data frame, whenever you want to create a data frame, you use the function called data.frame. So once you have data.frame, it depends on how you want to like structure your data frame. But because we've already have vector of interest, which is fact, we've already have that already. So what we do is that we create an x, like x equals 1. Then we have our y to take value from. It takes value from 1 to 10. That's what our y is going to take value from 1 to 10. And the variable we want After aside that one, we want to like include the fact vectors into the data frame, which is this. So then you have your data frame below here. So this is how the structures looks like. This is how it looks like. So these are exactly how data frame looks like. It's like in form of rows and columns. So that's one way to create a data frame. So also to like make it like more practical, let's just say we have age of how many students, age of, let me just say 5 students, 1 2 3 4 5, right? So we have the height of the students of 5 students, let's just say um, from 50 to 51. All right. One. Let's see something. No. Sorry. And just write this instead of 50, 51, 52, 53, and 54. Yeah. Okay. And just write this. And let me just say this is text. It's M So we have vectors of age, height, and sex. So what we want to do is that we want to create let's just say we want to create data frame called students information info. So we just have to just use our function called data.frame. So then we list the vectors name, that's age, height, and sex. Okay. Yep. So we're able to create that. Then we have the student info to be age, height, and sex. So in your data frame, the way the vectors are structured, the way the variables are structured in your data frame depends on how you want, depends on the level of information you put in the data frame or function. If you like bring height first, then height will appear first instead of age. So that's how to create a data frame. That's how to create a data frame. So, and you can manipulate data frame by, like, if you have 2 data frame, you can join them together. You can join them together. You can perform some kind of selection method. Okay, let me just briefly talk about that. So now we have data frame, right? So if I'm interested in working with only the age in the data frame, so I can access the age variable in the data frame various many ways. Which one of them is just like linking up with the name of the data frame, then using the $sign. Whenever you call out your data frame name and you use the $sign, it's going to like give a list of options. The options contain the variables in the data frame. So which one of it is age, height, and sex? So if I pick age, it's going to give me only the age information. So I can pick height too as well. It's going to give me only height information. That's one of the easiest way to like access information within the data frame. And another way is like you can use this bracket, like this cube brackets. I don't know if you see cube brackets. Once you click one is going to return only the first variable in the data frame. That's what one is going to do. If you choose 2, it's going to return the second variable, which is height. If you choose 3, it's going to return the third observation, the third variable. So now I might be interested in a particular row. I just want to see like, oh, the first student, I want to see the first student's age, I want to see the first student's height, and I want to see the first student's sex. So I might be very interested in that. that's where you use one comma. So whenever we are working with tables, I'm coming. Let me display this table so I can explain this. So whenever we are working with tables, this is our rows, like this is our rows, and this is our column, right? So this kind of stuff take like row first and column. So R is going to ask you, what row are you trying to like? If I want to access specific students, like I know the row number of the student, I want to access that student information. It's going to ask me, oh, what row is that? Because I'm interested in only like this student number one, and I'm not interested in a particular variable. I just want to see the set of information for that student alone. That was why I put one comma, and I won't put anything again. Then it's going to like give me the first student on the list, the first student on the list. If I want to see the fifth student, I'll just put this. So it's going to give me the information about the fifth student on the list. But if I'm interested in like seeing the fifth student, I want to know the fifth student height. So I can now come here and now specify, after I've given the row number, I can give the height number too, because age is 1, height is 2, and sex is 3, right? So once I put 2, it's going to return the height of the student. This is one of the easiest ways to select, manipulate and select specific information within the data frame. And if you want to like get like you want to get some, let me say, 2 variables out of the 3 variables we have, you can just come here and say pass your vector within it 2,3 is going to bring height and sex. Yeah, this is another way to like select. If I'm not I'm not really interested in seeing age, you can use -1. It's going to return height and sex too as well. So these are things you can try at your own time, try to like work within it. Why I use C is that C command C and C. Why I pass C into the argument was that when we have like multiple numbers that we want to like combine them, we use combine, which is C, or concatenate, as some people will say. So this is what this does. It's like passing a vectors to like select the kind of variable I want, out to return. So that's about manipulating, brief manipulation of data frame. So you can, if you have 2 data frame, you can join them, you can select, you can filter, you can subset variables, and all those kind of stuff. So this, we'll be talking briefly about the R ecosystem actually. So the R ecosystem now, like, it's just friendly the way we have been being introduced to R since last week, and executing functions. So something I want you to notice that R has inbuilt data that you can use for your own practice. So they have like a whole lot of inbuilt data, which when you run the function data, once you run the function data on your R, open bracket and close bracket, and you just run that particular line of command, you are going to see the list of free data. They are very free, so you can use them for your data manipulation, for your practicing. Like if you are like maybe bored, you want to do some stuff, you can just come here and pick up any data and try to like work with the data. So what you just have to just do is, when you pass the data, we are going to have like list of options, the data they have. These are data sets. So automatically that will pop up if you are using R Studio. So let me just pick one, which is this Irish data. So once I come here and say Irish data, so automatically this is Irish data. So because I passed in this data function, I passed an argument called Irish data, because Irish data is one of the data they have. Like once you just like you are going to see the list of the data automatically. So they have like multiple data. So then you run the line. Once you come here and just say pressure, or you can just say print in case pressure. You are going to have your data. Print pressure is equals to like saying I want pressure. So it's going to like come in. Okay. It's going to run that particular data, and so then you can like work with that particular data. That's what the data argument does. So that's what the data function does actually. So so now, because it's a function, you cannot just write data. It's going to give you error. No, it can just you can't just write data. Anytime you are working with function takes some set of arguments. So, and the arguments will be in brackets. That's how you know a function from, let me say, maybe why you've saved your object into name, which I can just come here and call Irish. It's going to give me my data because I've saved the data name to be like Irish data, right? But this function, whenever you're working with function, it takes your argument will be in brackets. So if you just come here and just say data, it's going to return error. So it's going to return error. So, and you can plot any data within the base R, the app data. This is CO2. So this is how the CO2 data looks like. Let's call CO2. Let's see CO2 data. Yeah. So let's see the structure of CO2. CO2. So this is how CO2 structures, the data structure looks like. This is CO2. So you can just come and just plot CO2 automatically. Then you have this kind of plot. You have this kind of plot. So now, this what we have been doing so far is like using the base R. Well, the base R, that is, if you want to compute anything, you compute them manually. But you need the more you need precision, you have to be very specific and timely actually. So that's why like team of statisticians, data scientists have come with some packages to like increase your speed actually, because there are some stuff you want to try to do. It's going to take more computing time without packages. So they've developed these packages which we are going to install in R. We are going to like load them in R, then use them to like perform some set of work and like what you intended in doing. So these packages, if you want to like load a package in R, you use the function. Okay, if you want to install the package first, you use the function called install dot packages. So because it's a function, you have certainly have some arguments in brackets. So you have to have some arguments in brackets. So now there is this common package called tidyverse. Let's try to load that. Tidyverse. So once you run this particular line of command, yeah, you see that R is going to display some stuff and tell you the downloaded binary package are available. Once you see this, the downloaded package and binary package are available in this, then your package is like successfully downloaded. Because sometimes you might have some error, maybe telling you about the package, the kind of package update your R can work with, and all this kind of stuff. So do well to read instructions, maybe error instruction, successful run instruction. You need to like do well to read them so that you know if the process you are trying to do is successful or not. So after we've installed dot package, this is like installing packages. We have like millions of packages in R. I know with time, as you try to like navigate R, you navigate your way in R, you get to know all these packages and what they do. Because I cannot come here and start telling you this does this. No. We can only teach you the background, like to be very strong, like in loading package, the theoretical background, what you need to know. So I believe as you start to practice on your own, you get to know what these package, each of them, what they can do. So whenever you want to like perform a particular task, you know which package you are expected to use to do it and make your work more faster and seamless, and make it like make your efforts not to be like more. It's going to like reduce your computing time, reduce the kind of effort trying to like write in base R, building your code one after the other. Within just one function, you can execute multiple tasks. Yeah. So if you want to like load the package, now we've installed tidyverse, right? So you are going to use the function called library. So once you put library in your you pass the function called library. In the library, it's going to ask you like this was asking you. Just see function as okay, function library. In normal standard library, you have different book in the library. So you have to like know the kind of book you need for you to read in the library, for you to be able to like borrow the book from the library. So now library, what do I want from my library? So I want tidyverse, right? I will just come here and say tidyverse. So automatically it's going to be like give you lists of libraries you have that's relating to tidyverse, because we have tidy R, all this kind of function like that. Then you run the set of command. So once you run it, automatically, if you did not have any error, then you've successfully load tidyverse. Then you can start using tidyverse. You can start using tidyverse. So there are tons of packages. So on in R that you can use. So I've talked about this. So in case you need help about on installing, you can just use. So whenever you need help about how to use the function in R, you can just use help function. You can use help function to like seek for help. So once I run this help 221 line, which is help in quotes install.packages, that is I'm asking help for that. So it's going to come to this help panel. It's going to like give you some detailed instruction description about the function install.packages, how to use it. And whenever you are seeking help, it's going to give you examples like on how to like navigate your way after reading the documentations and all this stuff. So now, and you can use a very simple way to get help. You can just put question mark in front of that function. So in front of that function, like, we use function data frame the other time. So let's just try to like use data frame. So data frame, right? So once I put help in front of data frame, I put question mark in front of data frame, it's going to like bring this description in the help panel, the usage, how to use data frame, the set of arguments that data frame takes. So you see, sometimes it takes rows name, check rows, check name, fix error, empty, and all this kind of stuff like that. It's going to tell you what each argument is. It's going to tell you what each argument is, and at the end of the documentation is going to like give you an example on how to like work with the data you are trying to work with. So yeah, so how to it's going to give you an example on how to work with the function you are trying to use. So and in R, whenever you use hash, so hash, like maybe I'm trying to like write sample, right? And I put hash in front of this sample, that means I'm adding comments. This hash, because we are using R Markdown now, we have to be very careful, because whenever you put hash in front of a function, that means we are passing comments. But whenever you put hash outside of a chunk, like this comment is like you are giving this stuff an header. You are trying to give this maybe stuff topic or topic, depending on the number of hash you use. But if it's in the chunk and you use hash, then you are passing the comments, like you are trying to like make a comment. So whenever you run this line of code, this specific function won't run. So let's try this. You see, this function won't run because it won't have effect on this chunk, because I've already put it in comments. I've commented out of the function I want R to run. So that's just for comments. So now coming to R Markdown. So R Markdown, so it's like a simplified version of makeup language. So what R Markdown does is that you just use it to like compile your code and your output into a simplified format, like maybe in Excel, in Word, in PDF, or web HTML. So HTML. So from there you can use it to like create websites. They use it to create websites, write blog, a whole lot of stuff. So, and this is what we are using. We are using R Markdown. We will not really go into details of R Markdown. We just like try to like run through the basis of R Markdown. So if you want to like explore R Markdown more, you can use this link. We provided a link in the lab section, like a link in the R Markdown file, where you can like try to like explore how R Markdown looks like and all this stuff. So we need to talk about headers. Headers are very frequently used on websites, magazines, and to like draw attention. Maybe you want to start, I want to like start my data analysis section. I can just use headers, data analysis, and all this kind of stuff like that. So now, when you are we have 6 type of headers, and as you try to like do them one after the other, it's reducing. You will see that there is differences in their size. So this is header 1. Whenever you put hash first in an R Markdown document, not in the chunk. Whenever you put hash in the chunk, hashtag in the chunk with a function, then you are commenting the function out. But whenever you put it within the R Markdown file, then you are trying to like create a section, maybe a kind of topic, subtopic, depending on how you use it. So whenever you use one hash, that is header 1. So you are going to notice that can be like the larger title of the document. Whenever you use 2 hash, it's going to like reduce the size of, it's going to reduce the size of the text. So that's like header 2. Whenever you use 3, you are going to see the size is going to reduce. That's header 3. 4, 5 to 6. We have 6 header in R Markdown. So whenever you just use hash, once you use one hashtag, it's like header 1. Once you use 2, that's header 2. And whenever you run it, you are going to see the way it displays. So the size decreases, and why the number of hashes increases. So that's that. And we have knit R. We have knit. This knit helps you to like knit your R Markdown file into HTML, PDF, or Word document. So whenever this knit can be found here, so this is knit. So whenever I just come here and just do something like this, like using this drop down list, you are going to see knit to HTML, knit to Word, knit to PDF. So from there I can determine the document I want my R to knit. But in case automatically you won't have some won't have like knit, you won't have like that knit option. So you have to install it using this function, install dot packages. Then you pass knit, you pass knit R as the argument in double quotes. So knit R as argument in double quotes. So yeah. So R Markdown, knit R, Markdown, pan document, and so on like that. That's how that's like the framework. Like, is it the framework? Yeah, let me just see. That's how the organogram of R Markdown looks like. Let me just use that word. Yeah. So that's how it looks like. So that's how it looks like. So you can like when you click on knit button, yeah, automatically it's going to like knit. It's going to knit into that. And I have showed us how to like include chunk in R Markdown. There is 2 ways you can use to include chunk. Depending on the kind of laptop you are using. Sometimes you can use Control Alt I for people using what's this, HP, like HP Windows OS Windows option. You can just use Control Alt and I plus I. It's going to like give you a new chunk. But when you are using MacBook OS, you use Command and Option I. So it's going to include a new chunk. So you pass all your commands, your commands and your function in a chunk. Then any document you want to write, maybe you want to interpret a result, you want to like write some stuff, you pass it into the R Markdown, we pass it into the script, not into the chunk. So that's how it is. So now we have chunk here. You can see this is chunk. The chunk, this is the chunk. So you can run the chunk. Once you run the chunk, you are going to see the output below. Definitely you are going to see the output immediately below. So that's how it works. So I've talked about installing and loading libraries. So another very crucial, like another important step you need to know is how to like import data. it's not really practical for R is not a data collecting software. So trying to if you have like millions of data now and you want to like start creating a data frame. Let's say you have a kind of paper data, like it was collected on paper, maybe due to registration system and all this kind of stuff, not online system, and you have them in tables, your paper tables, you have data on paper tables. It's impractical for you to sit down and come and be like, let me just say millions of data. Well, that has been done maybe in the 80s, maybe, yeah, kind of sit down and start like looking at the data, start creating a data frame to like get all the data on the paper into a data frame in R. So it's not really practical. Software like Excel, they use Excel for data collection sometimes. SQL, once you collect your data using SQL, from there you can like change it to like, you can export it and change it to like Excel file. You can change it to CSV file and all this kind of stuff like that. So now, you need to like import those kind of data into R to like work with them. So you need to like import them into R to work with them. So before I explain this importing data and setting work directories, let me just ask, is there anybody that has any question? Do you have any question? Do you want me to like am I too fast?
No, sir. You're right.
Okay.
No, sir, I'm not.
Okay. Okay. So now you need to like learn to like install like importing data actually. So you have to learn to import data. So but before we learn to import data, there's something I need to like point to you. Now it is called path and working directory. So it is called path and working directory. Okay, working directory is just like your local file. Okay, maybe I want to start a project and I create a folder on my laptop. I call it medical analysis, right? So I have my data. If my data, okay, I have my data in that folder. So if I come to R, I need to like set my working directory. If I did not like file a new project, because I showed us how to like create a new project last week. Once you just come to this file, you can file a new project, right? If I did not create a new project in R, like file a new project, my R might be working in another working directory. Let me just say my R is working in download working directory. So, and I have my data in medical file on desktop. So there is no way I can load that data. Like there is no way I can try to like want to load the data I have in medical file while I'm working with working directory in download. It's just as if you have a document on your desktop, you now went to download and start looking for the document. You can never see it. That's how it is. So you have to like go to the right folder, go to the right file, and like work with the right data in the right file. That's what paths and working directory mean. That is where you like save your R scripts. If you are just to stay organized, save your R scripts, your data, so that easily you can load your data like that without using some weird ways that you have to like keep doing all the time. So now you can know the working directory you are working with by using the function get wd. So once you type get wd, then you run this command line. You are going to see I personally am working with user, my name, which is Olofin do, document, and on that document I'm working with start clinic file. I have a folder created called start clinic. That's where the content of this class, the details are in that start clinic. They are in that start clinic. So you can try that at your end and see if you are working with, I know some people are very organized. You might have created a folder for start clinic and check. I know most likely you'll be working with maybe documents, your working directory and parts might be documents. Yeah, might be documents because maybe this is the first time of you like coming to using R, so might be document. So if it's documents, the next question you need to ask yourself is, how can I change? Okay, now my example now, I have my data on desktop and I'm working with download, right? How can I like change my working directory to move from download to desktop? That's the question now. That's where we have set WD. set working directory. So this set working directory is like in two form, right? So you can set working directory in two ways. Either using the function called set wd, or you use or you come to you use like a manual way of setting directory. You come to okay, yeah, you come to section. So once you go to section, you see set working directory. Then from there you can navigate your way. Maybe you can choose your own working directory by like looking for a file. So once you look for file, okay, let me just try this. Let me show you this. Once I just do this, automatically it changes my working directory to like that folder I picked. So when I come again and come around which working directory I'm working with, automatically it should change this because I've already set it to like to work from a LSTM folder. So it's going to start reading LSTM folder. So any data I want to like load from this my document start clinic folder, I won't be able to load it from there. So because I've already changed my working directory. That's one way to like load to like change your working directory. Another one is using the function called working directory. Then there is, if you are using, I think if you are using what's this name, if you are using Windows, so I think you go to your download files. Let me look for my download. Okay, let me look for this. Okay, I have a folder here, so I can click on this folder. I'll click on option. I'm going to copy the part. I mean, there is a place. I think it's mostly on that property because coming. Okay, get information, right? So get information under this. Let's see what we have. Yeah, I know in Windows are related. There is a way you see the parts. Like I think they used to have like 5 parts. So this is a new I'm coming. Oh, I'm sorry, I don't think I get how to check these details using this OS actually. It should be under get information. But I know it used to be under when you check your if you use like if you use these Windows, you are going to see it under properties. So you can copy the part to like the pathway. It's always having parts. So once you copy the part, you are going to see something like this. Like yeah, if you are using Windows, you are going to see something like this. It's going to like show this C. It's going to show this C. But what happened is that all this will be this slash will be like this. It's going to be like this. It's going to be in this format. This will be in this format. I think it's backslash. Yeah, I think it's backslash. So it will be in this format. It will be in this format. The only thing you just have to do is just like change them from this format. Whenever you copy your parts, if you are using Windows, you're going to change it to this forward one. That's the only thing you have to just do. Once you paste it in the setting working directory function, because it takes this argument. So this is what you just have to do. You are going to have this once you copy the parts of the file you want to work with or the folder you want to work with. You are going to have this part. You are going to have this part. So, and you pass it in quotes. Yeah, you pass it in quotes. So once you like run this line, it's going to like automatically set your working directory to that folder. So, and if you are using OS, this is how you are going to like set your working directory. I could not find how to like I could not find how to find that part. Yeah, because I'm sorry, I just started using Mac some days ago, so I don't really know much about how to get all these layer informations. I think it should be under this. It should be under this file. Yeah, so it just like saying from where it comes from. But ideally, you should have like if you are using like if you are using like Windows, you are going to have something like this, but it's going to be in that like that format I explained. It's going to be in that format only for you to just copy it and just like paste it, then change the slash from back to like forward slash. Then you set your working directory automatically to be where you want to work from. So and you can use that option of like that option of trying to like navigate using sections, and you have to navigate your way through. So you have to navigate your way through. Okay. Dr. B, I'm with you.
So thank you very much, Daniel. So I was also going to point out an easier approach. Sorry, I have a little bit of background noise. So there's an easier approach. So if you go back to your R, basically, if you save the R file in the same folder as the data, right? And you just ask it to set working directory as, if you go to, hold on, I believe if you go to edit,
Okay.
or is it, I'm trying to remember which one it is. Sorry, 1 second. So if you save the file in the same directory as your, go to session, sorry, not edit, session, and say go to set working directory and say to source file location.
Okay.
And if you just set working directory like that, you don't need to do anything else. You don't need all this code. You don't need, just save the file, the R file, in the same location as the data, and just tell R that you have set the working directory as the source file location. So wherever the R file is located will be the same place that you're going to work from. And I found that to be way easier.
Yeah,
You
exactly.
don't have to look for the code, you don't have to get the working directory, you don't have to do anything else. Just when you save the file in the same location as the code and work from there. I know it's not always practical for some cases. Maybe you don't have control of the folder, you cannot move the folder. So this process that you have explained is important, but this is an easier approach is to set working directory as a source file location. Thank you.
Yeah, thank you very much for sharing that. So yeah, I think that's way more easy. So now, so let's assume we've already set our working directory. So we want to like call in some data. We've provided some data which we said last week that you can download for we are going to use those data in this class where we have resident doctor, we have the height data, we have the BP trial, I think so, and some other data like that. So now I want to like, okay, I don't need this. Let me just, since I've set my working directory, so I don't need this. Let me just clean this. So now we want to like load our data. So we have different kind of software and their extensions. So when you use Excel now, when you save an Excel in when you save an Excel file, is it that you save it in CSV folder, you save it in CSV, you save it in XLXX. So or you save it in those are two extensions for Excel, if my memory serves me right. When you save data in SPSS, you save as SAV. So now if you want to like read, if you want to read an Excel file, maybe you want to read CSV file, or you want to read the extension, Excel extension itself. So you are going to need a package to do that. So that's why that install.packages makes sense. So you need to like install okay, let me just say install. You have to install read Excel for Excel file, and read R for CSV. These two packages are very, very important. these two packages, they are very, very important. So what you can just do is to just install them yourself. So you should just install them. I'm coming, trying to install, let's see, install those packages. So I'm really installing them. I have them already, so I'm really installing them. I pass them into a vector because I have one more than one libraries I want to install. That's why I pass the vector of those attributes into the install.packages function. So don't get confused. It's just like, trying to like create vectors, list of vectors in the install.packages. So I can now install them, like load them. You want to load them now to be like, you just install it, you download it. If you do not like kind of open, if you download R now and you install R on your laptop and you did not open R, you cannot use R without opening it. So that's what we want to do now. We want to like open these we want to open these packages. Like it's just like loading them in R to be very active. So read XL. So library read R and read XL. That's what we used to like read CSV file and Excel file. So now, if you want to check what functions are in read R, you can just like read R semicolon twice. If you put 2 semicolon, you are going to see all the list of functions that's contained that read R contains. All the list of functions that read R contains. So what we need here is that we want to read CSV file, right? So this is CSV. So that's the function we are going to use whenever we want to read a file called CSV. So you are going to use read underscore CSV. Then it's going to ask you the data name. Like, what is the data name you are trying to read? I'm trying to read resident doctors .cxv. So once I read it, automatically it's going to display my data. This is my data. Yeah. You know why it display my data here is that why it display my data on this command 353 is that I read this data alone without writing this data into object name or into like data name. So if I say, okay, let this be my underscore data, and I assigned it, that is, I assigned this resident doctor's data to be my data. Once I run this line of code, you notice it does not show any data behind below. Or else I want to like see it myself and say, okay, print my data using photo print, or I use print. I just use okay, my data. Automatically it brings it. So print is equals to just calling out the function name, like the data name itself, not without using print. So that's how to read CSV file. And it's the same pattern to read XLXX file too, which is for Excel. So you can use read this, or you can use read underscore Excel. Yeah, to read Excel. What you just have to just take note is that the extension file is in CSV, is in SAV, is in Excel format. So once you know the extension, you just come here and just like pass your name into this attribute. Yeah, resident name dot that extension file. If it's SAV, if it's for SPSS is SAV, you write this. If it's maybe we have some what are you calling SAS has its own, I think it's dot dt something or so like that. Yeah, for SAS. So the data depends on the file extension depends on the how you save it. And because you can save Excel, you can save from Excel you can save from Excel file to CSV from there. You just have to just know the file extension. That's what it takes. It doesn't take anything big like that. So that's how to read both Excel file and CSV file. So now we have some file, like we have SPSS that gives .sav. So we have SPSS that gives .sav. So this is how to like load data in SPSS. So you need a library called Avon. You need a library called Avon. So you have to like install packages dot Avon. So once you install packages dot Avon, so you are going to like load Avon. Once you load Avon, then you just same way read underscore SAV, because Excel file extension is always in SAV. So then you read the data. Okay, now let's assume that we've read a data. We've read our, let's go back to this, our resident data. So I've read my data, I've read my resident data, I've done a whole lot of manipulation in my data and all this kind of stuff like that. So I want to like save my new data. Like I want to save my new data. Like I've done so many manipulations. Okay, let's do something. Let's just say head of my data. So this gives the first 6 observations. So now let's say maybe I save this, I assign this to like, let me just say head underscore df. So now I have 6 observations here, unlike the previous one that I have 161 observations. So I can write this is my new data. Like maybe after manipulation of the data, you correct some data errors, discrepancies and all this kind of stuff. You adjust the data and you want to write your new data, you want to save your new data, you use the write function. Write. So if I want to save it into CSV, what is the data I'm trying to save? Head underscore df. Then I'm going to like, which name did I want to save it as? Let me just say new data dot CSV. So automatically on my laptop is going to save this data automatically. Let me show you. Start. Yeah. So can you see the data here? And I don't have it before. I did not have it before, but because I write it into that option, I should have it now. So now, if you want to save it as Excel, right? You're going to use Excel extension. So automatically, it's still going to save as Excel extension too. You are going to see that too of that data now. So can you see another one as Excel extension? So you can save it as SPSS extension too as well. Serve. Yeah. It's just for you to just change the extension. Oh, sorry. Well, if you want to write it into Excel extension, you are going to change this to write option into find that. You can use this. Yeah, I'm very sure you can use this. It writes into Excel. You can use this too. You can use this right into Excel. So yeah, you can use this. This is if you want to write into our file itself. Yeah, so you can write into CXV. So if you want to write into XPSS, you're going to use write underscore serve. Then you pass the same set of arguments you pass when you do CSV, when you do CSV, when you do CSV and Excel, you pass the same set of arguments. The only thing that will just be different is this function, which that one is write underscore CSV. This will be write underscore serve, and this extension behind dot what file location do you what file extension do you want me to like write it as. So that's how to like write the data. Like that writing data is like saving data, the new data in your already open file, your already working directory. So, and we provide some resources, as we've said, this is like giving you like a very creating a kind of familiar environment with R and giving you a very strong R background where you can like build on. So we have there is this package over here that you can use to like learn more about R. We have provided some resources and some cool resources that can help you learn how to like work around R, maybe in subsequent time after the class. You might want to like extend your knowledge about R in more wider range. then you can use all these resources. So I think here I come to the end of lab section 1 that should be completed last week. So do you have any question before we move to lab section 2? Okay, Yusuf, I'm listening to you. I'm with you. You can just unmute yourself.
Okay, thank you so much. And thank you for the class. I just want to ask, when you were speaking the other time, you were saying functions, and when you were calling some keyword. So I'm not getting it, because I think there is a function that can use in R when you like want to do some manipulation, which is just called the function. But then when you are using what keywords, so is there like a difference between keywords and a function as a function itself?
Some of the success stories here. So
Okay. Function in R. What function in R does is that it helps you to like execute a particular command. That's what function is in R does. So how we are going to like differentiate function from like, okay, function from, okay, let me say function from this my data. So like now, I've already write my data into data name and all this kind of stuff. Whenever you are using anything, any stuff that demands you to like write in a bracket in R, that's the function. So data in brackets is function. Mean in brackets is function. Sum in brackets is function. And something that is very popular to function is that they will always take set of arguments. They are always taking set of arguments. I can't just come and say just only mean. I will be expecting a mean what. But if I have okay, we have a kind of vector called age earlier, right? If I just come here and say age, automatically we're going to calculate the mean of age. That's function. That's how function works. But now, if as I've already write my my data into object name, right? I don't need to like come here and say add df in brackets it won't. This is not a function. So this is just like my data name that I just for simplicity. So that's, I don't know if I have answered your question. Okay, Dr. Abi, we can hear you.
Thanks. So to just add a little bit more to that question, Daniel is right about functions being, a word that you call and it does something for you. But there's also custom functions that you can write for yourself. You can write a code that maybe there's something that you want to do in R and there's no conventional function, there's no standard function that is available that you can use. So you want R to generate a table for you that includes mean, median, mode, right? Which is not traditionally what will be. Usually there'll be just mean, there'll be just median, there'll be mode. But say you want all three of them together and you want to create a custom function. So that's another thing that's called function. And very often when people think about functions, that's often what they're thinking about. But what Daniel has also said, where there's a word that you call and it does something for you, that is also a function. So there's the general function that is the functions that are built in R, inbuilt functions, and then there's a custom function that you can write for yourself. I'm not sure that we will cover how to write functions in this class, but we will focus on the functions that are related, that are inbuilt, and that will allow us to build up to do the analysis that we want to do for the class. Thank you.
Thank you very much. Alfred, you can unmute yourself.
Yeah, all right. Thank you very much, Daniel. Can you hear me?
Yes, I can hear you.
All right. Yes. So I tried performing the earlier operation while you were teaching it. I couldn't get it right. I don't know. It's stored data also a function, or how did you create the function yourself, or it's an inbuilt function? Because eventually when I tried running it, it told me it could not find age or something. but like I couldn't run it earlier.
Okay, you were trying to like create a data frame, right?
The data frame, yeah.
Okay, creating a data frame. Okay, now if you create age is not a function. You are just trying
Yeah.
to like
Yeah.
you are just trying to like save a vector into a vector name, right? Called age.
Yeah.
Now, in the process of creating the data frame, that's
Mm,
object you use called data frame.
mm.
Data.frame, it's a function.
Okay.
Data.frame, it's a function. So now if you've already run your age, your height, and your sex, you will now pass those set of arguments, like those set of vector name into the arguments that data.frame.
Yeah.
Yeah. I don't know if you would like to like share your screen briefly so that we
Yeah, I'm
can
happy to. I'm happy to share my screen.
stop sharing. Yeah.
Share entire screen. Then I'll go to the place. Please confirm if you can see my screen.
Not yet.
What about now?
Not yet.
Oh, let me stop sharing and share again. Sorry. Oh, is it coming up now?
Yes, I can see your screen now.
So yeah, I tried these. I don't know if you can see it.
Yeah, I can see your screen. Okay, now can you go to line 2?
Okay, I'm there.
I like from 2 to line 4.
To line 4.
Yeah, from 2 to
Okay.
4.
Okay.
Go to that run section and run it.
Okay.
No, or run. No,
I'm trying
no.
to look for Ron.
Very close. Coming.
Okay, I've seen it.
Okay, yeah.
Okay.
So now, if you check your environment region, you are going to see that age has appeared, height has appeared, and sex has appeared, right?
Yeah.
So go back to that line 7 and run line 7 now.
Okay. Should I highlight it before running?
You don't need to highlight it. Just click, put your cursor and go and click on run. Yep. So that's how it works.
Okay.
So now, if you need you want to see your student data now, you just want to like use print function, then pass student underscore data into the print function.
So what is the print? I should just type print.
Print, yeah.
Okay.
Then pass the student underscore data.
So should I put quote marks?
No.
Okay. Oh wow. Thank you very much.
Yeah. And if you don't want to use like print, like you can just write student underscore data. Automatically it's going to like show your data.
Oh,
Automatically. Yeah.
Well, yeah, it's showing it.
So
yeah, thank you very much. I'll stop sharing now.
And point to note, the only time you use double quotes, you use quotes in a function is if you are trying to like call an attribute. Now you've already write your data into object name. You don't use quotes because that's not an attribute. Your data is an entire structure. So now, but if in my data now I want to select sex to be only, I want to select only male students. That's when I will say, okay, select male attributes. Like you are going to say, oh, select sex equals, you put the double quotes and pass male. Then it's going to like kind of select male. That's attributes. I'm telling him that I want only this. That's like attributes stuff. But this is like you've already write it into a data name. So that's not an attribute. So Thompson, we can hear you.
Hi, yes, I had a more general question about RStudio. So when I installed RStudio, it took all the files, or it copied all the files from my document folder into that fourth quadrant where the files are kept. I wanted to remove it because I didn't necessarily want those files in that environment. But when I checked online, it's saying that if I try to remove the files from RStudio, it will remove them from my computer. Is that actually so or not?
Okay, if I may get you now, when you install RStudio, like all your documents are like showing. So let me share my screen so you can, maybe I can get what you're saying clearly. So all your documents are showing here, right?
Yes.
Okay. You don't need to like worry yourself. Maybe why your documents are showing there is that maybe you try to like the working directory you are working with is maybe download or documents. So now,
Okay.
because I'm working with this working directory now, makes me have all these folder over here.
Right.
If I set my working directory to be like in my actual documents, I'm going to have all my documents over here.
Okay.
So that doesn't
But
really matter.
I didn't set a working directory though. I just
Yeah.
downloaded R. So I'm curious as to why they ended up there.
Yeah, they ended up there because maybe you are working with your documents working directory. So what I'm going to advise you now is that you can open a folder for this section, like or for the class, like start clinic, then put all the data and your R markdown script inside it. Then you can now set your working directory to be inside that folder. Automatically, you're going to have your files in that folder appearing in your R markdown. You won't have your general files in R markdown.
Okay, that's fine. And as far as you're concerned, removing them from the RStudio won't delete them from my computer. It should not.
There is automatically it's going to delete them because there is no way you can remove it without deleting it. I think so. So now if I delete this, automatically it's going to delete from my laptop. So you don't have to delete it. What you just have to do is like create a new folder for the class and put your data into the folder, then set a working directory from your document to the folder you created. You have your data, you have your documents that are not external documents, just only for the class. So
Okay.
yeah.
Okay, thank you.
Welcome. So I think now we can now move to this class since we don't have any question any longer. So yeah. So now I'll be talking about
one question.
okay.
Yeah. Do you have an access to the data?
Do you have what?
Do we also have an access to the data you are using?
Yes, the data link were shared, I think, some weeks ago, and even last week the grant access to. Once you check the Google Classroom, you are going to see the data in the Google Classroom.
Yeah, so if you check in Google Classroom, under data sets, so under data sets, there's like 7 or 8 data sets that we're going to use throughout the class. So you can download them from there.
Okay, I've seen them. Thank you.
Okay. I don't want to like murder your name. Please, can you just like unmute your mic? I can see your hands up.
Hi, good afternoon.
Please, can you what's the actual pronunciation of your name?
Gwibite.
Nibite.
Attention, Gwibite.
Okay. Yeah.
So I'm trying to I was on code. Let me just confirm the code line again. That's 350 where library read R.
Okay.
So, and I was trying to like bring up the file, the residence doctor file. And when I copied the file path and put, I have an error popping up.
Okay. Can you share your screen?
Yes, I can.
Okay. Let me stop presenting so that you can share your screen.
Okay, 1 minute. I'm looking for not to. Can you confirm if you can see my screen?
Yes, I can see your screen. I can see your screen.
So here is what I did.
Okay. Okay.
Yeah.
I said something towards like changing from backslash to like forward slash. So you need to change. Can you see line 350, right?
Oh, okay.
Change those.
Oh,
slash.
okay. Oh, thank you so much.
Yeah. So
Mhm.
no. So I'll be talking about quantitative summaries and data visualization. I hope we can cover this. This is very, very much interesting because I know during the week you guys have done like the mean, the measure of spread, measure of standard spread and central tendencies. So I know you've done also some maybe visualization techniques like all this kind of stuff like that. Okay, now we have the height data. So I don't know if anybody has, if you have the height data. I'm coming. I think I have the height data. I think I should. Start. Yeah. Okay. It's good. Library. So I think it's high time you can just like load your height data. Yep. For now, so we'll be working with height data. Let me display the data. Read. Yeah. So that's what happens. Okay, let me show you this. So now let me show you something. I was trying to read the height data. So the height data is in an Excel extension, right? But I use read underscore CXV, and I passed the Excel extension and the data named dot Excel extension. So when I ran this, when I was trying to like view the height data, can you see in the format you read the data? Because that is not like the actual extension for the data. So you have to be very careful when trying to read your data. Make sure your extension matches how you read the data.
Please.
Yeah, Yusuf, your hand is, yeah, you can go on.
Sorry, I can't see your screen. I don't know if I'm the only person.
Oh, sorry. Yeah. You can see now, right? Can you
Yes,
see now?
I can show now.
Oh, thanks for
Yes.
raising the observation. So I was trying to like read this height data. So I want to like read this height data and save it in HT name. Like I just want it to be in HT. That is my HT should represent my height data, right? So I use CXV instead of, because the extension is in Excel. So I passed the right name and the right extension in this line. So when I read it, I want to display my data. So I click on the data from the environment, HT. So I could see something that is not making sense. Why that happened is that I'm using the wrong function to read the right data, right? So I have to change this to like to match the actual Excel extension. So now if you click from here, you're going to have your data. So you have to be very careful about the function and the extension. They are very, very important. So now we have our data here. So you can display your data by just like clicking this place. You are going to, by clicking the environment, the name of the data on the environment region. So you're going to have your data displayed this way. So now we need, something you might, if you want to like do okay, you have the data and you want to like know what happened in the data. We have something we call data exploration, trying to like explore the data, knowing the spread, the central tendency, the distribution of the data, and all this kind of stuff like that. So it might interest you to want to like see the first the head of the observation, because if you have like, let me say you have like 10,000 rows, you cannot load all the data and start looking at everything. No, it's not possible. What you might want to see is like the head, maybe the first set of observation, which there is a function called head. So it displays the first 6 at default. It's going to display the first 6 observation of the data. Head, and I pass my HT, which is my my height data. So it's going to show the first 6 observation. So if I have like multiple variables now, this I have like actually this height data, I have like 4 variables, which is the IDs, the heights, the height 2, and the height 100, right? But if I have like multiple, let me say I have like 10 variables, it's going to like show and write some instruction that you still have like some other variables elsewhere, that kind of stuff like that. Okay, so let's see head of, yeah, we load one data earlier. It's called, what's the name of the data? Resident doctor, right? So now when I check the head of resident doctor, it only showed 1, 2, 3, 4, 5, 6, 7. So we still have like 3 extra variables. So you can come like using the right arrow, it's going to show the rest. So you can move back again to see it. So that's what it does. Automatically shows the first 6 observations, the first 6. So now you might be interested in want to see like, I don't want to see 6, I want to see 10. What happened to 10? So you set your n. It takes another argument called n. That is when you do your head into bracket HT, n equals 10. It's going to show the first 10 observation. That's it. If you want to see the first 10. So if you're interested in seeing the last 10, we are going to use the function called tail HT. At default, it's going to show you the last 6, but you can set it to equals to 10 too. So it's going to show you the last 10 observation. That's if you want to see like the first few observations in the data set. You might want to see the structures of the data, like the structure of each, the composition, the structure of each variables in the data set. So you are going to use str. It's like a short form for structure. So str ht. So it's going to tell you that id is numeric in nature, height is numeric in nature, height 2 is numeric in nature, age is numeric in nature. So let's do that for our resident doctor. So once we do that for our resident doctor, we are going to see age numeric, mental score numeric, job satisfaction numeric, age category. Because this age category is in categorical order, like from 25 years to 29 years, 35 to 39, 45 to 45, like kind of like it's going to tell you that this is a character type. Can you see? This is character type. So, and it's telling you that this format is in SPSS. It's telling you this format is in SPSS. So I think I saved the CSV one. So this is how the CSV one is going to look like. Very neat. So character, numeric, and so on. So someone is reading, and yeah, I can hear you. You can speak, please.
Okay, yeah. So I'm having some troubles when I run my arrow lab too. I'm getting like errors in library, and then I run the HT, and then I'm getting errors too. I don't know whether.
Can you share your screen?
Yeah. Okay.
And while she's sharing, can I just ask that the link to our lab 2 be shared in the chat, please?
Okay, the link to our lab 2 coming. Let me see if I can share that while she shares screen.
Okay, can you see?
I'm coming. Sorry, just give me some minutes. Okay. I'm coming. Yeah, you can just go to okay, let me just copy this so you can see. I doubt if it works, because the easiest way to like get the link is to go to the class Google Classroom. Yep.
Okay.
Yeah, I can see your screen.
Okay. So yeah, I'm just getting errors. I don't know what
Okay. Now, I said something about reading errors, right? The first thing is that when you try to like load that library, it told you you can see the error that say error in library read R. There is no package called read R. That is, you've not installed read R.
Okay.
So first thing you have to do is like you have to use your install.packages. But there is
Oh.
easier way to like read that. Is that can you see like
Install those packages. Where is it?
wait, can you see that exclamation showing like that kind of a warning sign? No,
Here.
like at the top, can you see one? Line
Okay.
one.
At the
Can you
top.
see that exclamation, like that warning exclamation sign above line one?
Above line 1. Okay, this 3 dots.
No. This yellow, something like with yellow background.
Okay. Yeah, packages. Yeah, are not installed.
So
Okay.
just click install.
Install. Oh, okay.
So this is going to automatically install because you are using R Markdown.
Oh, okay.
It shows that error because you are using R Markdown. But in case maybe it does not show that, and you notice you don't have a package, you just use install.packages.
Oh, okay.
Yeah.
Sorry, the link that you shared was for lab 1.
Oh, okay. Okay. There is lab 2 too. Dr. B just dropped lab 2, so I'm sorry.
Okay.
I need that answer.
All right, thanks.
Okay, so from here, then
So, and I think another error you might be having is that you need to set your working directory to like be your own local file, because this is like Dr. Abiyo's working directory.
okay. How do I do that?
Okay. I think this is still loading actually. So
Oh, okay.
okay, can you just go to where you have your file? Maybe do you create a folder for this class? Yeah, can you go to that folder, please? Just navigate to the folder. So
Okay, yeah.
go to that biostat course, click on that biostat course. So coming, okay. I'm coming. Okay, these are your details, right?
For the class.
Yeah,
The
click on
data
download.
resident doctor.
Click on download. Go to the download. No, like download. No, beside that biostat course, like, can you see this? How
Okay, I don't have any file on download though. Like everything is here. That's how I'm looking. Like
yeah, I want you to go to download. You know, before you get into this file is under no, like don't minimize. Can you see this download? How can I?
no, see, I know. See what I'm saying there. My documents are not in download. You're not understanding me. I put everything that I need for in this place. Like if it's not here, I don't have them in download.
Yeah, you know what I want you to do is that wait, can you open that file?
My download is here.
No. Like what you opened earlier, just open it back again.
Which file? Okay, let's see. Is it the resident doctor?
Just go back take a step back to download. You know, from that biostat courses, go to download.
Okay.
So now locate that bio. So now you can now use option. Click on option, like, you know, I think it's right click. Is it right click? Option that gives you option to the file, like options. Okay, go to properties.
Okay.
So I'm coming. Copy this location extension.
Where?
This extension, like this. Can you see the location? Extension. I think, yeah. Copy this. I think you still need one more extension that covers this biostats class. Okay, Can you close that? Open the
Copy.
file.
Okay, I should copy it.
No, close it. Close this.
Oh, okay.
Close it. Open this biostat courses. Okay, come in. Can you like right click any of the documents? What is this?
Mhm.
Go to properties. Okay, can you copy this? Copy
This
that.
one.
Yeah.
Okay. Mhm.
Yeah, copy it.
Mhm.
Okay, click OK. Can you go back to your R Studio?
Mhm.
So go to that setting working directory. No, that line 14. Line 14.
Okay.
So from that C,
Mhm.
highlight from that C
Okay.
till the end. From the C, no, leave the code. Leave the code. Okay. Leave the,
Okay. Okay, from here.
from the C, no, C.
Ah, okay, okay, okay.
From the C to the end.
Mhm.
To the last one. Yeah, before the code.
Mhm. Mhm.
Then paste. Control V.
I should do Control V. Okay.
So now you will now change all this backslash to forward slash.
Oh, okay. Okay.
So can you try to run it? That
Run
line.
the code again.
No. The line itself. No,
Oh, okay. Yeah.
that line. Yeah.
Okay.
So you've changed your working directory to be that file. So if you have your data in that file, automatically you should be able to like get it. So go to the I think line 20.
Okay.
So you can clean from that HT. Can you clean from height from H backward?
Let me hear, Abby.
No, like the inside the quote from height like H that backward, not forward, backward.
Wait. From age. Okay.
In the quote, in the quote.
Okay, in the quote. Oh, okay.
Yeah. No, wait, from C, just start from C
Uh-huh.
to H.
To age. This is height. Uh-huh.
Yeah. The H, just before, don't clean the H. From H, just back.
Okay, that's height now.
You only want the heights in the quotation.
Yeah, go backward.
I should not clean the height.
Exactly, yeah. So you can clean that.
Uh-huh.
So you can put another quote at the beginning because you cleaned the quote already.
So which one will I put?
Just one double quote once. Just like shift double quote.
Shift, double quotes. Okay.
You can run this now and let's see what happens.
Oh.
So you have your data already.
Okay. So what is next?
Yeah, so you can run the next line of code.
That's this height, HT.
Yeah, that's Ed. You want to see the first 6 observations. So now you can now join the section.
Now the errors is now. Okay.
So
but like this one is not coming here. I'm not seeing them.
You don't see them because you did not write them into the environment. If you write them into names now, you have it there.
How do I write it?
You are only having Ed, like you're only having what you just want to see is that you want to see the structure. Can you see the results?
Okay.
You can see the results. You can see the result downward. So you can see the result.
Okay.
Yeah, we are not writing it into the environment.
Into that place. Oh, okay.
So we are just trying to like do some quantitative summaries. So
Okay. Okay. So from here now, how do I move?
so you have to like join the section back.
Draw the section back. How
Like,
do you mean?
join the section, our section now. We've not gotten to where you are moving to now.
Oh, okay, okay,
We
okay,
just added
okay.
the section 2.
Okay, so like I'm good here, right?
Yeah, good.
Okay. Thank you. Stop sharing. Thank you.
So so now, as I was saying, so you can see the structure of the data by using str, and you pass the ht argument into the str. So you pass the ht name, that is, I want to see the structure of ith data. So now it's going to give you the structure. From there, you can know what structures, if you want, if you are changing it, because sometimes R can recognize some data, some variables in some structures you did not like. So you have to like put them back in the structure you like. So now you can access individual structure. I was saying something then that if you like earlier, if you want to like access variables in height, once you just use $, and if I click height, it's going to display only the data elements in the height variables, which is in the height data, right? So if I want to see the observation, like the ID's number, if I height $ID. So now what you want to see now, you want to see the structure of only height. Once you pass this height $height, like $ht height into the structure function, it's going to show you the structure of height. So it's going to tell you the height variable in the structure of height data is numeric. So that's that. So now the central the measure of central tendency, which is basically the mean, the median, and the mode. So this wants to help you to know the central, like the center of the data, what the means gives, what the median gives. So we have the mean function, so which is this. Once you like mean, then you pass your numeric data variable into the mean function. You are going to have the mean of your observation. That is, we have 100 and how many observations? We have 96 observations, and we have 99.7. This is the mean. That is the mean height of maybe the student, of the patient, of the observation. The mean height of the student is 99.773 or thereabout. So something you need to notice is that if you are dealing with, maybe you have, let's just say you have age, and you have you have 1, 2, 3, 4, 5, 6, and like you have NA. NA is missing observation, right? So now if you check our age, you are going to see we have NA, and you want to check the mean of age now with NA. Let me just say age. It's going to give you NA. Why it's giving you NA is because there is NA in the observation. But if you say I think remove NA, right, or omit NA, I'm coming. I need to look up this function. Okay, sorry, I forgot that. R dots NA.rm, that is remove NA. Once you put through, it's going to remove NA and recalculate the mean. So you have to be very, very sure if you have NA, like missing observation in your data set, you have to like set n.rm to be true. It's going to remove NA automatically. So that's how to use the mean function. We have the median, which mostly represent the 50%. That is, it shows that this is the middle observation. 50% of these observations, maybe 50% of the heights of students have heights greater than or equals to this middle value, while 50% has heights greater than or equals to that middle value. That's what 50% median represents, just middle 50. So now once you just pass, you have the argument and the function called median, then you pass your variable name. It's going to give you the median. So the median in this case is 100%. Is 100. That is, the middle point of the height of the student is 100. That shows that, like, technically 50% of the students have heights greater than 100, and 50% have heights greater than 100. 50 has heights lesser than 100. 50 is just like the midpoint. So we have mode. Mode tells you the most frequent observation in a data, right? The most frequent observation. So if you use the function mode, it's going to give you numeric in R. R does not have a function called mode. R does not have a function called mode. Like function mode that calculates the most frequent observation, R does not have that. So what we have done is that we have created a function. Someone was asking earlier that function, this thing like that Dr. B was like explaining that there are some functions, that there are some things you want to do in R that has not been done in R before, that you can create your own personal function. This is one. So where we created a function called get mode, we write the function, and we want the function to take v arguments. So we want the function to take v arguments. Then we go to the next line and write we want the function to have like something called unique, give us the unique set of values, which is maximum. Like you have to start looking at this from here. We match this. It's not something you have to like bother yourself about. We use the match function to match the v and the unique. We use we tabulate them. After tabulating them, we get the maximum value, which we use which maximum. Then after using which maximum, it was wrapped against this function. So that's just it. You can just come here and just run this. That's because if I said I should explain this, it might be too complex. So whenever you write a function, if I write a function now, okay, let me use this as example. Okay, let me say BMI. Let me just use BMI as example, right? BMI. I write a function, BMI, function body, function. I want you to take height, right? BMI take height. Let me say my height is h, and I want you to take weight, right? So I write my function body as BMI equals weight divided by height square, right? So I come here and I said return BMI. I don't want you to worry about this because this is not, I just want to like explain something. So now I've created a function in my R automatically called BMI. So whenever I write BMI and I've opened the bracket, it's going to ask me H and W. So if height of that person is, let's say height is 1.72 and weight is 60. So automatically R is going to calculate the BMI because I've already written a function to like calculate the BMI. So now, because we've created a function called get mode, right? So once we try to like get a function called get mode, it's going to ask us v. So what is our v? Our v is the height, right? HT underscore height, $ height. So the mode is 100. 100 is the most frequent observation in the data set. So that's how to like use the function. So, and you can save your results, like your mode results, which is 100. You can save it into name. You can write it into object 100. We write it into object called results. So whenever you need results, you can say print results, or you can just write results. Then you have your 100 back. So any question? Any question? Okay, no question. Okay, now we want to move to proportions. It's from proportion you calculate percentage, right? So we try to like, okay, we have table. Let's create a table. Table function height, our height data, and we use the height 100. So this is a character type of data. So it has a benchmark. Maybe I don't know what the benchmark says, but it has a benchmark actually. Let's just say maybe 100 represents patients with height greater than some benchmark, and 0 to represent patients lesser with height lesser than some benchmark like that. Let's just say maybe the benchmark is 50. Let's say we say, oh, our whenever 1 represents patients with height greater than 50, and 50 is patients with height lesser than 50. That's what this means. So we create a table. If you pass your table, you have your table function and you pass this set of arguments into the table, you are going to have this. This is the table. This shows you that patients with like height greater than 100 is 44. That's their frequency. And patients with height greater than 50, like, is 52, right? I don't know if you get. I'm just trying to like explain this. Like it's like you are trying to like group them into their categories using tables. So, and it's going to give you the frequency. So now you can write this table into a function called height table, right? So once you run this height table, you are going to have 0 and the frequency, 1 and the frequency. So now we want to create a proportion, like a proportion table, right? So we have prop dot table function. This create a proportion. If you want to create a proportion manually, is 44 divided by the sum of 52 plus 44. This is how to create a table for this. If this is how to create proportion for patients with height 1 that is patient greater than 50, their height is greater than 50. This is how to create the proportion actually using like a manual kind of computation. This is how to create the proportion. But automatically to create the proportion, you use prop dot table. So you pass your height table automatically, your height underscore table automatically into this prop dot table. So it's going to calculate this. It's going to get the proportion for 0 and for 1. So that's how it works. So now you can try to like write this your prop dot table into like, let's write it into prop underscore table, right? Let's write it into prop underscore table. So now it's still the same thing like what we've done. I've showed it earlier. So you can try to like round. I'm coming prop dot table underscore table. Sorry. So you can see that this has how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8. I think it's 8, which you cannot like present this kind of result. So you can round this figure up into, let's say, into two decimal places by using the function called round. Can you see round? Round proportion prop underscore table. Let's round it into 2. So we've rounded it into 2. So you can round it into 32. But let's round it into 2. We've rounded it into 2, right? If you have a proportion table, multiplication of proportion table by times 100 gives you the percentage. Yeah, I have a proportion table. I have a proportion of like a male to female to be like 0.45. If I multiply it by 100, it gives me percentage. So what you just come to do is just like basic arithmetic by multiplying this by 100 gives you the percentage. Am I right? I'm coming. Yep, it gives you the percentage, right? So it gives you the percentage. So once you multiply a proportion table by 100, it gives you the percentage. That's how we've come to this. So this round dot table takes this round takes digits. Yeah, digits equals to, that is, it rounds this proportion. It rounds this proportion into 2 decimal places, then you multiply it by 100. That's how to get your percentage. So now you can now say the percentage of patients with height greater than this cut mark is 46, and percentage of patients have this height lesser than this is 54. So that's that. So now, wherever we have two or more variables that we want to do their quantitative summary simultaneously. So we have a package called table one. Table one. This is table one. So once you install table one and you load table one, right? So you can now try to work with that. So now what we do is that we create variables. Okay, before we use, okay, let's just start. We create variables by saying by creating vectors of height and height2 in the variables. So we use a function called create table one. When you use question mark to read what this function does. So can you see create an object summary, both continuous and categorical variable. So it takes some set of arguments. It takes variables, that is the variables you want to summarize. It takes structure. When we talk about structure is groups. If you want to structure the variables, maybe I have height now, I want to structure it by genders. I want to see how the genders work together with the structure. So, and all other sort of things like that. So now we come back to this function and come and put the set of arguments. It takes vars, right? And we've created vars called vars. Those are the variables we need. Actually, you might necessarily not create this and just reference your height data and say, let me see the HT data again to see where those locations. This is 1, 2, and 3, right? Let's see something. 2 to 3, right? Then you come to structure. We don't have any group, so you leave it data equals HT. Do you want it to include any? That's false. That we want to remove any missing observation. Then we have to create. This is very, very important. This is very, very important. Then, if this does not work, this is very, very important. Let me see something again. I'm coming. I love trying stuff. No, it doesn't work. So we have to create that vars. That vars is very, very important. So our vars, this is our vars. So we've already create two variables called height and height2. So create table one. It takes set of arguments. Vars means variable. So what are the variables you want to summarize? You want to summarize height and height2, which is in vars, right? So the structure, are we grouping it by anything? No. So we just write structure and we just put comma. Data equals HT. That is what data has these two variable name. That is HT, right? So include any. Do you want it to include any? No, we don't want it to include any. That's why we put false. So this false, you can write it in this format, or you just only put F, depending on how you want it. So once you run this, you see it's going to give you the mean and standard deviation. This is the mean of height, and this is the mean of height2. This is standard deviation of height1, and this standard deviation of height2. And we have 96 observation. So now I must point something. If you write this function into let me just say summary one. Okay, summary of height, right? Let me just write it there and show you something. Then you now use the summary function. Summary. You want to summarize summary underscore height. Yeah, it's going to give you this long table. Can you see this long table? This is summary of quantitative variables, continuous variables, which is going to give you the number of n, the number of missing, percentage of missing. We don't have any missing variables in the data set. It's going to give you the mean. It's going to give you the standard deviation. It's going to give you the median. It's going to give you the 25 percentile, the 75 percentile, the minimum height per group, the maximum, the skewness, and the kurtosis. So this is going to give you this stuff. So if you like save this, create table 1, vars, variables, struct, comma, height, and height data, and first you don't want it to include any. That's include any equals f. So it's going to give you, and you summarize it, it's going to give you this. So any question concerning that? Okay. No. So so now if you want to like, if you already know which measure you are interested in, so you can use the print function. Now you already know what you like, the measure you are interested in. Like maybe I'm just interested in only I'm just interested in the mean and the standard deviation. So you can just pass this non-normal also. But I think it's just the easiest way you can do that. I'm coming. You just print table 1, yeah, without even writing all these, like writing all these arguments. Once you just like print table 1, it's going to give you what you need actually. So summary heights, yeah, it's going to give you the mean and the standard deviation. So more, I think this has a lot more to do. Is maybe if you want to select the median, you want to select some maybe kurtosis, I think you should take some argument too in between argument actually. So now if you specify a variable in the non-normal function, you will get the median and the IQR. Okay, now I have to say this. You know, when we talk about non-normal, like, you know, normal distribution, it is the one that has to do with like the mean and standard deviation. When you set this non-normal equals to height, that is, maybe you did not believe the height too as a normal distribution, then you won't. Anytime you are not a data is not normally distributed, it's mostly the measure of central tendency used is median, because median is not sensitive to outliers, and the measure of spread is IQR, that's interquartile range. So when you set this to be equals to height 2, it's going to give you height 2 is going to give you the median and interquartile range, because you are telling her that you want to see like this data seems to be not normally distributed, so I want to see the median and interquartile range, because the median and interquartile range is the measure of spread and measure of central tendency for normal data. So that's that. So that's that. So I think this section is just for 2 hours from 7 to 9. So my own time. So I don't know your time. So from 7 to 9 my time. So I think this is where we are going to stop this week. So next week we are going to pick it up from next week. So what I would just want you to do is that I want you to like go over this code, try to like practice yourself, so that you can get what we've discussed previously last week and today. We can be able to like move more faster, because we are slightly, let me just say slightly behind schedule, because we are expected to like cover this section today, but due to the fact that, you know, everybody including me, we are just new to we are trying to like navigate our ways. We are having some bunch of error that we are trying to like correct in between the sections, so that is definitely affecting the way we move. So you can just try, and in case you are trying to practice on your own, then you hit you hit an error that you cannot solve, you can take a pre-screen, put it in the Google Classroom, or if you need like maybe one-on-one conversation, you can email start.clinic, yeah, course, I think it's called course.startclinic, something like that, I think. Yeah, so yeah, you can just email. Once you check the Google Classroom, you should see the email, so you can email. So I think Dr. B is going to respond to you. Thank you for attending this section. Thank you very much. Do you have any question before we call it a day? So okay, so free to leave. Okay, someone is okay. Jojo, we can hear you. Can you speak?
No, sorry, I did not raise my hand. Sorry.
Oh, okay, okay, it's fine. It's fine. Yeah. So